There is some evidence that high school students justify cheating in class on the basis of poor teacher skills or low levels of teacher caring. Students appear to rationalize their illicit behavior based on the perceptions of how their teachers view cheating. Poor teachers are thought not to know or care whether students cheat, so cheating in their classes is okay. Good teachers, on the other hand, do care and are alert to cheating, so students tend not to cheat in their classes. The following are hypothetical data similar to actual research results on this topic. The scores represent judgments of the acceptability of cheating for the students in each sample. So here in the photo, we can look and see that there are three treatment conditions taken, where there's a poor teacher, average teacher, and the good teacher. And the part A says, why can we not do an F-max test to evaluate the homogeneous variance for the samples in the study? So the homogeneous variance takes the largest variance over the smallest variance. But even by looking at the chart, we can see that the sums of squares are significantly different from each other in each treatment. And we can also see that the n is also different. The n is not the same. So just by looking at the chart, we can tell that we will not have homogeneous variance in this particular study. Part B, explain how the values for t and x are calculated for a given condition. Why do you think that we use a t symbol instead of a notation sum of x's? So the t is calculated by adding all the scores in each treatment, and the sum of x squared is calculated by simply squaring the scores in each treatment. And then when you have the sum of x symbol instead of the t, that means that it represents all the scores combined. Part C, use a one-way ANOVA for independent groups to determine whether there are significant differences in students' judgment about cheating depending on how they see their teachers. So one-way ANOVA, our null hypothesis is going to be that there is no difference between the mean of the poor teacher, the mean of the average teacher, and then the mean of the good teacher. And then our alternative hypothesis says that there is differences between the poor teacher, the average teacher, and the good teacher. And then next we're going to start to calculate our formulas. The first thing we want to do is calculate degrees of freedom between, which is going to be k minus 1. That's going to give us 2. And then degrees of freedom within, which is going to be n minus k equals 21. And then df total is going to be 23. You check yourself by adding your within to your between, 21 to 223. So that's going to give you 23 when you check yourself. So now we can see that our degrees of freedom is correct. So we can go ahead and go further. Next, we want to calculate sums of squares between. And when we calculate sums of squares between, we're going to use the formula here. So basically we take t squared, or the treatment totals in each condition squared, divided by n minus g squared, or the grand total of all the scores added, divided by capital N, or n is the total scores in all the conditions. So basically when you calculate all of your math using Please Excuse My Dear and Sally, you end up with 61.3. 61.3. Then we'll erase that. Next up, we're going to do our SS within, which basically is the total sums of squares, which in this equation, in this problem, is going to give us 72. So next we do sum of squares total, which equals the sum of x squared minus g squared over n that we had in our previous problem. So basically, you just bring those same numbers down. So that's going to equal 456 minus 88 squared over 24 that we had in our previous problem. And we calculate everything together here using please excuse my dear Aunt Sally. 1.33.3 is what you end up with for your sums of squares total. So then go ahead and erase that. So now we can move on to calculating our mean squared, and the formula for that is ms equals sum of squares over df. We're going to actually calculate mean squares twice, one for between and then one for within. So the between mean squares, we're going to take our sums of squares between, which was 61.3 over degrees of freedom between, which is 2, and then that's going to give us 30.65. Then our within sums of squares was 72 over our within degrees of freedom, which is 21. So within treatments mean square is going to give us 3.43. So now we've calculated our mean squares for between and within. Go ahead and erase this part again. And now we're going to go ahead and calculate our F ratio. So MS between over MS within equals 30.65 over 3.43, which gives us 8.94. And then we use a chart to calculate our critical value by using our degrees of freedom, and that's going to be 3.47. So we can see that 8.94 is greater than 3.47. So therefore, we go ahead and reject the null, saying that there is a difference in students' judgment of cheating based on their teachers. And then we can also calculate our effect size. That's the word I was looking for. Go ahead and erase this. So effect size, that's a mu symbol. This funky n symbol here, squared, is SS between divided by S. S total equals 61.3 divided by 133.3.46. So 46% is the effect size, and I believe that's a large effect because it exceeds 0.25, so it's definitely a large effect that we have here. So then Part D says, explain why we cannot do a 2-keys HSC test to determine the source of the observed treatment effect, if any. we cannot do a Tukey's HSD test because the ends in our table in each treatment is different. If you look again at the table, our N is 6 for poor teacher, 8 for average teacher, and then 10 for good teacher. If they were all the same number, then we can go ahead and calculate our Tukey's HSD. But for this particular problem, we cannot do that because the formula wouldn't allow us to do that because only one N is allowed in the formula. Part E. Even without planned comparisons, we can make an educated guess about which group is driving the treatment effectiveness just by looking at the means. Which group is it, and how do we know? So the poor teacher group is driving the effect because there seems to be a greater deviation than in the other treatments. Yeah. And then part F, again, we have to calculate the N symbol squared for the current study. And then we already did that, and we came up with 0.46 or 46%. And yes, that is a large effect. And then part G, then we summarize our findings. So basically we say that we reject the null, stating that there is a significant difference in students' judgments about cheating depending on their teacher. And then the notation for that will be F, review the freedom 2 and 21, parentheses, brackets here, equals 50.92. I'm sorry, equals not 50.92, 8.94, and then the value less than 0.05, and then N squared is 0.46. So that's kind of the statistical notation that you would write for the problem in APA style format.